So in the next topic, we are going to discuss formula and variation. It is in two parts, the formula part and variation. In this video, we focus on variation. So we have different types of variation, and we'll be talking of the four types. The first type is what we call direct variation, and variation comes from the word varies. So we are going to see how two quantities are going to be in direct variation. So two quantities and x and y are in direct variation proportions. If x increases or decreases, then y also increases and decreases in the same ratio. And normally read this one as x varies directly as y, which is normally written as x. This the values assigned as y. Then to remove the values as values assigned, we normally put an equal sign and multiply with a constant. And this one we put x equals k times y. And k is normally called a constant of proportionality. Let's see an example. Given that y varies directly as x squared and y is equals to 12 when x is equals to 2, find the value of y when x is equals to 3. So we are told x varies directly with y squared, so we can write y varies directly as x squared. So this is varies as, then we'll be required to have it as an equation, so y is equals to the constant of proportionality x squared, and this relationship between y and x with k as a constant. So we'll be required to get the equation first, so we substitute these values we are given. Y is 12 when x is 2, so we'll have k, then 2 squared. So this will give us 4. So 12 is equals to 4k, and k therefore is equals to 3. So the equation connecting y and x only will be y is equals to 3x squared, since we have already found what k is. Then find the value of y when x is 3. So we are going to take y is equals to 3 for k, then we substitute our x value as 3 and it is squared. So y will be equal to 27. The next type of variation is inverse variation. And two quantities are said to be inverse variation if product of xy equals to k, and therefore we can also have x equals to k over y. And in inverse variation is when one quantity decreases, the other one decreases. And for in this case, we are using if one increases the ratio p to q, then the other one decreases in the ratio q to p. So then we write this one as x varies inversely as y. When we move and have it as an equation, we introduce a constant. So we shall have k of x is equals to k over y. Then we have joint variation. This is where variables depend on two or more variables. An example, we can take the volume of a cone, which is given by a third pi r squared h. A third pi is a constant, so the two other variables are r squared and h. Therefore, we can write this one as volume varies as the square of r and h. So when we are having these ones as r and h, two or more variables that v depends on, then that one is a type of joint variation. So let's see some examples. The quantity p varies jointly as quantity q and r. So that statement only requires us to have something like this. The first statement says p varies jointly as q and r. Therefore, p varies directly as q. and P also varies directly as R. Therefore, P will be equal to K Q R. So given that P is 700 and Q 400, R 300, then from that statement we'll be able to find the value of K and get the equation connecting P, Q, R. So we substitute. P is 700 and Q is 400 and R is 300. So we are going to have 700 equals to 12, 120,000 K. Therefore, K will be equal to 700 divided by 120,000. So K is 7 over 1,200. So the equation connecting P, Q, R will be P is equal to 7 over 1,200, then P, Q, R. Then find the value of P when Q is 250 and R is 150. So we just substitute because we have the values of P and Q. This is 7 over 1,200 multiplied by 250 multiplied by 150. And after evaluation of this one, we get P as 218 and 75.75. So in the next example, we are given P varies as Q and R. Find the percentage change in P when Q is decreased by 12% and R is increased by 12%. So this is about percentage change. So P, the initial P will be equal to K, Q, R. So we want to form a new P. We can denote this one by P1, and this will be equivalent to K. Q is decreased by 12%. Therefore, Q will be 88%. So 88 over 100 Q. And R is increased by 12%. Therefore, R, the new R will be 112 over 100 R. So if you multiply this one, we'll find our P1 will be equal to 0.9856 KQR. So P1 is equals to 0.9856 KPQR. So KQR is the same as P, so we can say P1 is equals to 0.9856 P. So percent change, the new P to be P1 minus the old P over P times 100, which will give us 0.9856 minus 1 times 100. And the answer will be negative 1.44, which we say it is 1.44% decrease. The percentage change will be a decrease in P by 1.44%. The question is the pressure P over gas varies directly at temperature T and universally as its volume V. So from that, we can get the relationship P varies directly as T and universally as V. Therefore, P is equals to K T over V. Find the equation connecting PV and T if P is 800. So we just substitute in this. 800 is equals to K multiplied by 300 divided by 600. So K will be equal to, give us 2, so this will be 4, so this is 1600. So the equation connecting P, T and V will be given by the substitution of this. So P is equal to 1600 T over V. Then we are told hence find V if T is 400 and P is 2000. So P we substitute. We know that P is equal to 1600 T over V. So we substitute in this, we get 2000 is equal to 1600. T is given as 400 and we don't have V. Therefore V will be equal to 1600 times 400 divided by 2000, which we get as, this will be V, the volume is equal to 320 meter cubic. Next, three quantities P, Q are such that P varies as the square of Q and inversely as the square root of R. So the first part will give us variation as this, as the square of Q and inversely at the square root of R. Therefore this will be P equals KQ square over root R. That's the first part. Given that Q increases by 5% and R decreases by 36%, find the percentage in P. So we go for the new P, we can call it P1. We are told Q increases by 5%, so the new Q will be 105 over 100 squared. Then we are told R decreases by 36. So if R is decreasing by 36, then it remains 64 over 100 R as a square root. So this will be, it can be written as K into 1.05 Q squared over the root of 0.64 R. This is the new P. After evaluating this, we are going to have 1.05 squared divided by the square root of 0.64, and P1 will be equal to 1.378125 KQ squared over root R. This one is equivalent to P, so the new P is 1.378125 of the original P. So percent difference, we get 1.378125 P minus the original P over P times 100. The P will cancel out and we get the percent change as 37.125%. So P will increase by 7.125%. We look at formula and variation, and particularly on partial variation. partial variation is where we have two variables that are related in the formula, like the equation of a line, which is given by mx plus c, y is equals to mx plus c. And I want to give a few cases here. If c and k are constants, while x, y, z are variables, then if y is equals to c plus kx, this one we read it as y is partially constant and partially varies as x. Number two, if we have y is equals to c plus k over x, c and k are constants. Therefore, we say y is partially constant and partially varies inversely as x. And number three, y is equals to cx plus kz. Therefore, we read this one as y partially varies as x and partially varies as z. We are going to do some examples to illustrate the partial variation and see what happens. So, what examples? Let's work the following examples. X is partially constant and partially varies as y. So that one we can write it as x is partially constant and partially varies as y. So we change this to x is equals to c. This is already a constant, so we introduce a constant on y so that we can have x is equals to c plus ky. When y is 2, x is 30. So we form the equation here, 30 is equals to c plus 2k. And when y is 6, kx is 50. X is 50 is equals to c plus 6k. Then we are told find the relationship between x and y. That means we need to work for this, get the constants, then substitute in that equation. So we'll have to solve this equation simultaneously. And in this case, if we subtract this one, we get 4k negative is equals to negative 20, which means k is equals to 5. So taking one of the equation, we can get c. So c is equals to 20. So the equation connecting will be x is equals to 20 plus 5y. So the equation connecting x and y is x is equals to 20 plus 5y. Then part B, hence find x when y is 3. So just substitute x is equals to 20 plus 5y. When y is 3, we shall have x is equals to 20 plus 5 into 3, and then our answer will be 35. This is 15, we get 35. The next example, a varies partially as b and partially as the square root of b. So from this statement, we are going to get a varies as b and partially as the square root of b. So in this case, to remove these varies as sign, we are going to have, we can have mb plus n root b. We introduce two constants that we had it there, c and k, then work out the equation. So when b is 4, a is 22, we'll have 22 is equals to 4n plus the root of 4 will be 2n, and when b is 9, a is 42, so 42 is equals to 9m plus 3, the root of 9 is 3n. We are going to solve this. When we solve for n, we get n is 3 and m is equals to 4. So the equation connecting this one will be 4 connecting a and b will be a is equals to 4b find A when B is 25. So we are going to use this. A is equal to 4